The point I'm trying to make to them is that it's not the difference in the candles and that makes something float or sink. It's not the difference in the liquids that'll make something float or sink. It's the difference in the density of the floating object and the liquid that you put it into. It's not that this candle is heavier than the other one. It's not that it's more or less dense than the other. It's that the candle, and both of them, are less dense than the liquid they're floating in. And in this case, they're more dense than the liquid they're floating in. So we're comparing the object to the liquid and not to each other.
The majority of flat earthers counter the argument of gravity with the notion that relative density can account for the downward bias we see on our everyday lives.
There is no downward bias, Ranty. Things fall down simply because they are denser than the medium they are in. Things rise if they are less dense than the medium they are in. We live in a medium of air. Most things are more dense than air, therefore most things go down. However, there are some things that are less dense than air, and they rise. Now, if we lived in a medium which was a lot more dense than air, you would see a lot more things rising. Would you then tell me there is an upwards bias, Ranty?
Everyone on Earth knows that if you watch an apple break free from the tree, it will fall to the ground.
It will fall to the ground as long as nothing's there to stop it, yeah, as long as the density doesn't change, yeah. But if, for example, you've got a tree there, you've got the apples and you've got the ground. Okay, so we've got like a distance between the ground and the apple basically on the tree. Okay, the apple falls. It hits the ground. What distance did that fall? Okay, now we put a paddling pool, which goes halfway up the tree, filled with water. Now the apple falls. How far did the apple fall? Did it fall the same distance, Ranty? No, it didn't, did it? This time it fell into the water and then it floats in the water. Why does it float in the water? Because it's less dense than the water. Again, relative density.
Does relative density disequilibrium also work when compared to mass attracting mass?
Mass hasn't attracted mass for over 106 years. In fact, it never did. It was a misconception. But now Einstein comes along and debunks mass attracting mass. But carry on.
Well, let's just start first and foremost with Newtonian physics and the notion that Einstein debunked Newton. What a load of old cobblers that is.
Einstein did debunk Newton on many things, not just from a force to not a force, but from the speed at which gravity acts, from instantaneously to the speed of light. Also the geometry. Also, what big G stands for. There's a lot of things that Einstein debunked Newton on. So, yeah, carry on.
Around at the time when Sleeping Warrior found a citation in which he stated that Einstein's general theory of relativity superseded Newton's law of gravity.
This is an egg.
It does supersede Newton's law of gravity, especially on your model. Hence, Mercury, hence, as you get further and further out in your model, so as you go further and further and further out, you know, into the galaxy or into the next galaxies outside the galaxies, that's when Newton's law basically doesn't work anymore, because it's not the inverse of the distance. But yeah, that's for another story, but carry on.
That the incredibly stupid Anthony Riley needed to make an entire case that Newton was debunked and no longer does mass attract mass. The stupidity level at this point was maxing out, but rather than being outright dismissed by the Flerfs, they ran with it. Often now you will hear,
but he's right, mass does not attract mass thanks to Einstein. Mass no longer attracts mass. It is just mass following a geodesic, a path, if you will. It's like you getting in your car and driving to the shop, but then claiming that the shop attracted your car. Did the shop attract your car? No, it didn't. You just got in the car and drove your car to the shop. There was no attraction there, was there? The shop did not attract your car. You followed the path, the road, in your car to the shop. You followed the path to the shop. You was not attracted by the shop. The shop did not attract your car. It's not an attraction. It's simply mass following a geodesic path, following a path, if you will. So, no, there is no mass attracting mass, Ranty. Get up to date, please.
Bleat on about how Newton's laws are worthless and how All of gravity is a bending of concepts such as space and time.
Correct. Concepts. Mathematical models. Yes.
Like little children and have no idea of how any of this interlocks with each other. And if they do, then they are just being dishonest toe rags.
Based on Newton, there's a force equation to gravity, but
That's
if
incorrect.
you come to the present
Sorry, that's
gravity,
incorrect. Do you want to just stop a second, Anto? According to Newton, that was superseded 106, almost 107 years ago. Did you not know that?
yes, gravity today is a bending of space and time.
Right, so why are you telling us what Newton said? I don't get it. You're telling us about something that's 107 years out of date for your argument? Why are you mentioning Newton? It's been superseded. It's not a force, as you just stated. According to Newton, it's a force, but that's been superseded by bending space-time. That's correct. So let's not talk about forces of gravity because it's not a force. End quote.
Excellent.
End quote, George Musa. Not really a force at all. End quote, Prof. Brian Cox. So we're not going to be claiming we've got a force to worry about. So when you said the thing it does, what is that exactly? What is gravity?
Exactly. Gravity actually, again, as you mentioned, is the bending on space and time based on the mass.
I see. What's time? Stop. What's time? Bending of space and time, you said. What's time? Is it something that we can bend?
No, it's
Sorry, stop.
based on
Stop. You said we're bending space and time. I asked what time is and if we can bend it, and you say no. So we're not bending time then? What are you talking about? What is this nonsense? So gravity, not a force. It's not time bending because we can't do that. So when you said we're going to concern ourselves with what it is, what is it then? Well, it's not bending space-time, that's a concept, and it's not a force. So we're still at the stage where I say, what's gravity? It's not anything at this stage, because it's not a concept, it's time, bending, because you can't do that. And it's not a force, that was replaced, superseded 107 years ago. We all clear on what gravity isn't? You're still yet to tell us what it is.
They pretend that the Cavendish experiment was a one-off event that happened.
Yeah, and I'd also like to add, because I've been thinking about this. So you have objects which can be 4D, right? You can't actually show me a 4D object, but if you Google like 4D object, it will bring up different names of 4D objects and give you a rough example of what it looks like. I thought 4D was 3D plus time. So 3D, the 3 dimensions of space, plus the 1 dimension of time. So isn't a 4D object just the 3 dimensions of space and the 1 dimension of time? Isn't that just a 4D object? Rather not a shape, really, is it? It's just the 3 dimensions of space, which we've already got, and the 1 dimension of time, which we apparently already have. So aren't we already in 4D? And therefore, what is an object that is 4D? Just an interesting thought that went through in my mind. But yeah, be interesting to hear your thoughts on that. Carry on, Ranty, please.
Centuries ago, in some old woodshed out in the back of some farmer's field. This is how they downplay that experiment in order to try to convince their audience that this is the only time it ever happened. What they won't tell you is that this very experiment is conducted hundreds of times in universities all around the world. In fact, a database has been made of all the different materials used as to show that the experiment works over and over again. In this paper here, we can see how the gravitational constant is measured currently. Teams of researchers from China and Russia recreated the Cavendish experiment. In the first approach, the researchers built a device consisting of a silica plate coated with a metal hung in the air by a wire. 2 steel balls provided a gravitational attraction. The force of gravity was measured by noting how much the wire twisted. The second approach was similar to the first, except that the plate was hung from a spinning turntable that kept the wire in place. In such an apparatus, the gravitational force was measured by noting the rotation of the turntable.
Do not say gravitational force. Gravity is not a force anymore, thanks to Einstein. But do carry on.
In both approaches, the researchers added features to prevent interference from nearby objects and disturbances, including seismic. They report the measurements here and here, and both of which the team claims are more precise than the 2 previous measurements. To put it easier for the Flerfs to understand, on the local level, i.e. here on Earth, Newton's laws of gravity works amazingly well, and out in the cosmos, Einstein's general theory of relativity works very well.
You say Newton's law of gravity works very well here on Earth. Tell me, Ranty, when have you tested this? Show me you testing this, because I don't think you have you? Yet you say it works amazingly well. How do you know that without testing it? Believing what you're told, are you? Now, for starters, like on the surface of Earth, I will even beg the question with you and say Earth is a ball right now. And I will beg the question with you of that. Right. Now, how did you determine, so say I'm standing on the surface of the ball, how did you determine the distance between my mass and the centre of the ball? Can you tell me that, Ranty? And while we're on that subject, it's not actually the centre of the masses. There's actually a lecture with Richard Feynman which shows you that it's not actually an attraction, which is not attraction anymore. That's 106 years out of date, as you have been told many times. But yeah, it's not actually from the centre of masses. So again, you have a slight problem there. But yeah, anyway, carry on.
There is always room for improvement, but this is currently our best understanding of how things work. To summarise, Einstein did not supersede Newton. In fact, he broadened the research into gravity. Just because an article once used the word superseded does not mean that the Flers have debunked gravity.
There's a problem though, isn't there? Like I said, Einstein has superseded Newton, not only just in the force region, but in the geometry and, you know, from 3D to 4D, which is the geometry, or like the speed at which it acts, many things. But also, you bringing up the Cavendish experiment, it debunks Newton, Ranty. Think about it. Newton's first law, an object at rest remains at rest unless acted upon by a force. Well, those balls are at rest in the Cavendish experiment. So, therefore, according to Newton's law, the balls at rest should remain at rest unless acted upon by a force. Gravity is no longer a force. So what force causes the balls to move? Because under Newton's first law, the balls at rest will remain at rest unless acted upon by a force. Gravity is not a force. So what force caused the balls to move? Because it wasn't a force, was it, in your model anymore, because gravity is not a force. So therefore, the Cavendish experiment debunks Newton, because Newton's law tells us the balls will remain at rest. Because they are at rest, they will remain at rest, unless acted upon by force, in which case gravity is no longer a force thanks to Einstein, therefore the ball should remain at rest. So are you debunking Newton's laws now? All you people, Ranty, Cavendish, you all debunking Newton's laws now? That an object at rest will remain at rest unless acted upon by a force, which gravity isn't a force? Think about it.
Jerks they are, right? Moving back to the apple on the tree though, why did the apple head towards the ground?
Before we move on to the apple and the tree, how about we talk about Cavendish some more? So, Big G calculates, right? You can get Big G out of it. Tell me, Ranty, what was Big G? Was it what Newton said, which is the proportionality constant connecting the gravitational force between the two bodies with the product of their masses and the inverse square of the distance? Or was it what Einstein says, which is that it quantifies the relationship between the geometry of spacetime and the energy momentum tensor, also known as the stress energy tensor? Which one was it, Ranty? Which G did you calculate? How did you determine whether it was Newton's G, which again is a proportionality constant connecting the gravitational force between the two bodies with the product of their masses and the inverse of the square of the distance, or was it Einstein's, which quantifies the relationship between the geometry of spacetime and the energy momentum tensor, also known as the stress energy tensor? Which one was it? Because all you're saying right now is it calculated Big G. How did you determine what Big G was? Not just the measurement of it, but what it was actually measuring, and who was right in that regard? I'd like to hear your thoughts on that, Ranty.
Well, gravity is mass attracting mass, so simple.
Gravity is not mass attracting mass. It's 106 years out of date. As I've already told you, the mass follows in mainstream consensus, in Einstein's version now, because that is mainstream consensus now. He superseded Newton. I know you don't like hearing it, but he did. And now it's no longer mass attracting mass. It is mass following a geodesic, following a path. Your car was not attracted to the shop, was it? No, your shop did not attract the car. All you did was follow a path to the shop. There is no attraction, Ranty. Thanks, Einstein.
Answer there. But how does relative density disequilibrium stand up in comparison? Let's find out. What is RDD? Well, if an object has mass, then depending on its surroundings, it will move to the area of least resistance.
And you saying that right there tells me right now that you don't have a clue what least resistance even means. But anyway, no, that's not what it says. Basically, if an object is more dense than the medium it is in, then it will fall. If an object is less dense than the medium it is in, then it will rise. So what you're saying right now is a complete and utter straw man, completely and utter wrong. And I don't really understand how you can get this wrong, being that you've apparently watched the videos on relative density disequilibrium. Anyway, carry on.
In other words, density of the medium around it will determine where the object goes.
No, not just the density of the medium around it. It's not just determined on the density of the medium around it. It's also determined on the object's density. So you can have a density of a medium, let's say 10 kilogram meters cubed, around an object. That's not going to give you the direction. You need the object's density too to give you the direction, hence why it's called relative density.
In the case of the apple, the argument is that once it breaks from the tree, the air around it has less mass, and so it will fall through that mass until it meets something of greater mass to stop it.
No, the argument is the apple is more dense than the air, therefore it falls down. Until something can stop it, like the floor, or until it meets a medium which is more dense than the apple, or the same density as the apple. But as long as the medium is less dense than the apple, the medium will not stop it.
And I really have to thank Simon Dan for this. On his Friday show, he said something that was mentioned briefly, but which destroys RDD forever.
I think his point, and the usual flat earther stance on this, is that his phone is denser than the air around it, therefore it falls. Well,
Correct, Simon Dan.
my phone is also denser than the air above it. In fact, if you want to be really technical about it and really accurate, the air above it is very, very, very slightly less dense than the air below it. So,
Okay, so like you says, the air above it is less dense than the air below it. Yeah, so what? Did the air less dense above it suddenly become more dense than it, Dan? No, it didn't it? So if the object is more dense than the air, yeah, and then you have less dense air above it, it's still more dense, isn't it? It's still more dense than the less dense air. So you bringing up less dense is kind of irrelevant. Do you know what I mean? Like, if you want it to rise, then you need it to be less dense than the air. So, being that the air is less dense above the object, did the object now become less dense than the less dense air above it? No, it didn't, did it? The object actually became more dense than the less dense air above it. You know what I mean? Like, it's still more dense, so your point is irrelevant, but yeah, carry on.
doesn't a phone move upwards if that's the case? The phone moves down for a reason.
It doesn't move upwards because the phone is not less dense than the air. So saying that the air is less dense above, yes, the air is less dense above. Okay, so did the phone suddenly become less dense than the less dense air? No, if it wasn't less dense than the normal air, then why do you think it's going to be less dense than the less dense air? It's not, is it? It's going to still be more dense. It's going to be more dense than the normal air that you're on about, and it's going to be even more dense than the even more less dense air that you're on about. It's still more dense, so it's not going to rise. The phone needs to be less dense than the medium. Is the phone less dense than the air? Whether it's above it, or below it, or to the sides of it. Is the phone less dense? No, it's not, is it? The phone is still more dense, therefore the direction is still down.
Why don't you ever think about that one, Mikey, yeah?
You see, the atmosphere has a
Why don't you have a think about that one, Simon Dan, yeah?
density gradient. The higher up you go, the air is thinner. The air has less density, which means that the instant the apple is no longer supported by the tree, it has to choose a direction. Now, if
Apples choosing direction. Wow, I didn't know apples could choose things now, Ranty.
D is real and that the apple will go towards the area of least resistance, then it will actually go upwards towards the sky.
Oh, Oh, so you do know what the area of least resistance means then? It's funny because earlier in the video it didn't seem like you did. But yeah. Carry on.
Why is that? Well, on either side of it, the air is the same mass. Underneath the apple, the air has a greater mass than the air above the apple, even if it is microscopic.
Okay, so let's look at your diagram here. The apple. Is the apple more dense than the density of the air below it? Yes. Is the apple more dense than the density of the side of the apple? Yes. Is the apple more dense than the less dense air above the apple? Yes. So is the apple more dense than all of those things? Yes. So the direction's still down. Again, if you want the apple to go up, you need the apple to be less dense than the medium. Is the apple less dense than the medium beneath it? No. Is the apple less dense than the medium on the sides? No. Is the apple less dense than the medium of air above it? No. Therefore the direction's still down.
This is an undeniable fact. The air above the apple will have proportionally less mass than below it. So, the fact that the apple goes towards the area with greater mass flies in the face of the Fler's RDD nonsense. In fact, when you compare the two theories side by side, then the clear winner is Newton's law of gravity. Mass attracts flies in the...
Okay, so let's go back to this, yeah? Now let's change it for a rock and change the medium to water. Oh, the rock in water falls down, yeah? Towards the more mass, you would say. Now we have a cruise ship and we put it in the water. Now where's the cruise ship going? Is it going down? Is the cruise ship going down, Ranty? Or is it floating on top of the water? Huh? Yeah, floating on top of the water, isn't it? Now what has more mass? The cruise ship or the rock? Yeah, exactly. And again, this whole thing right here is a straw man because again, the apple is still more dense than the air. It's more dense than the air beneath it. It's more dense than the air to the sides of it, and it's more dense than the air above it. Again, if you want the apple to rise, you have to have the apple be less dense than the medium. So just saying that it's less dense above the apple changes nothing. The object is still more dense. How can you not understand this?
Fler's RDD nonsense. In fact, when you compare the two theories side by side, then the clear winner is Newton's law of gravity, mass attracting mass. For RDD,
Mass does not attract mass. Einstein superseded that. Are you saying Einstein's wrong now then, yeah? That they're not following geodesic paths then, yeah? You're saying Einstein's wrong. You know what I mean? You've already demonstrated Cavendish, well, brought up the explanation of Cavendish and brought up the Cavendish experiment, which debunks Newton's law. An object at rest, the walls at rest, will remain at rest unless acted upon by a force. Gravity is not a force anymore since Einstein. Therefore, the ball should remain at rest. So you're already debunking Newton's laws, but carry on and say Newton's right, even though you're debunking his laws straight away.
work, if you were to take a tennis ball and throw it upwards, giving it both force and direction, then it should, in theory, continue going higher and higher and higher as it moves towards the less dense medium. But that is not what we see. What we see is a release.
Oh my days, Ranty. No, the ball is more dense than the air. As it's rising and rising and rising, it's still getting more and more dense than the air, isn't it? That means it's still acted upon by a downwards force of relative density, because the relative density disequilibrium force acts in the downward force, in the downward direction, because the object is more dense than the air. So why is it going to keep going up and up and up and up and up? Okay, you've applied a force. Well, guess what? There's a relative density disequilibrium force acting in the downward direction because that ball is more dense than the medium it's in. Therefore, the direction is down. So there's still a downward force counteracting your upwards force of you throwing it. So it's not going to keep going up and up and up and up and up, is it? No, the ball isn't less dense than the medium that it's in, is it? That's where you get the upwards direction from being less dense than the medium it's in. The ball is not less dense than the medium it's in. So it's not going to keep going up and up and up and up and up, is it? Because it's not less dense than the medium it's in. It's more dense than the medium it's in, meaning that there's a downwards force of relative density disequilibrium acting on the ball. So that downwards force is going to overcome your upwards force of throwing it. Seriously, man.
Of the ball and of slowing down of the ball. till the point that it stops going higher and then returns back down to the Earth. Now, what causes that? Because with the theory of RDD, then the ball would continue moving towards the area with less mass.
Oh, because it's not, it moves to more mass or it moves to less mass. Seriously, Ranty, man. This is so annoying because you don't even see how wrong you am. Like, this has been explained to you ballers many times. That's not how it works. The object is more dense than the medium, then the direction is down. The force acts in the downwards direction. If the object is less dense than the medium, then the force acts in the upwards direction. All you're doing right now is throwing a ball which is applying an upwards force, but the ball is more dense than the air, which is applying a downwards force. You know what I mean? Like, seriously? You just don't understand RDD. You're straw manning or something because, wow, the face palming. I need other protection, let me tell you that.
Not. Essentially, if RDD was real, then if you were to take a jump upwards, you should continue to go upwards towards the less dense air. A bit like Superman trying to reach.
Let's put you at the bottom of a mercury, right? So we'll have a liquid mercury medium. We put you at the bottom of liquid mercury, right? We're holding you there, whatever. We get you to jump up. Are you going to carry on going up to the top of that mercury? Yes, you are. Why? Because you're less dense than that mercury. So yes, you would keep going up in that scenario. But in air, when you jump, you are more dense than the air. So yes, you apply a force which makes you lift off the ground because you jump, right? That is one force going up. Now, there's another force acting on you going down, and that is because you are more dense than the air. Therefore, the relative density disequilibrium force acts in the downwards direction and pulls you back down to the ground. But, well, pushes you back down to the ground. But the thing is, like, you're trying to say that you should just jump and relative density will tell you that you keep going up. No, that's not, because you're denser than the air. Therefore, there's a downwards force of relative density disequilibrium acting on you. You're not less dense than the air, are you, Ranty? Ah, my days.
Batteries from the sun. So, there we have it. RDD is totally debunked once and for all.
More like, there we have it, you debunked Newton's law of an object at rest will remain at rest unless acted upon by a force with the Cavendish experiment. Well done, Ranty. And well done on showing that you still don't understand what gravity is now. It's not mass attracting mass. That was superseded 106 years ago by Einstein. It's now mass following a geodesic. No attraction involved at all. So pretty much your whole video was pointless and wrong, because not only did you get Newton wrong with mass attracting mass and Einstein now with the consensus and that, not only did you get mass attracting mass wrong, not only did you say it's a force when now it's not a force anymore, but you're also completely straw manning and getting RDD totally and utterly wrong. So your video was basically completely and utterly pointless, wrong, and misinformation. But yeah.
Thanks, Simon Dan, and also to Conspiracy, who I am reliably informed has also mentioned this before. That will do for this one, and we'll see you all in the next one.
Hopefully the next one will be a correction of how gravity isn't a force, mass does not attract mass, and how it's basically just a mass following a geodesic, not any attraction, just like the shop and the car example. There is no attraction, it's simply following a path. And hopefully you will correct yourself, understand and learn, and now put out more information about what relative density disequilibrium is, which what you said is a complete and utter straw man and complete and utterly wrong.
And the point I'm trying to make to them is that it's not the difference in the candles and that makes something float or sink. It's not the difference in the liquids that'll make something float or sink. It's the difference in the density of the floating object and the liquid that you put it into. It's not that this candle is heavier than the other one. It's not that it's more or less dense than the other. It's that the candle, and both of them, are less dense than the liquid they're floating in, and in this case, they're more dense than the liquid they're floating in. So we're comparing the object to the liquid and not to each other.
Oh, and one more thing, Ranty. You made a claim that Sleeping Warrior's degree was a fraud. You got anything to back that up? Please back up your claim.